Alright, sure. It's quite hard when you've had a break from things and suddenly you've got to go back to a section you've been doing. And I don't want to kind of. No, it's recap's difficult. What I'm going to do is I'm going to actually just start, and then when we get stuck, that will involve a recap. Okay. Or do you want to recap?
No,
let's just see this. Okay.
Right. Don't take the advice.
Okay, quick recap. Right, start on time, 5 minutes for me.
Okay, I will.
Okay.
No, it's my turn. You always time. No, you always time.
Greg, come on. Okay.
Okay, 3.
Wait. Okay. So, we're going to just start from understanding shifts of graphs. Okay.
Can I start?
On your mark, get set, go. Okay? So, just transformations. Yeah, we're going to get there. Okay, I'm going back to page. Okay, so if you've got your notes, we're on page 21. Does anyone not have notes here? I've got it there. Okay, right. So on page 21, okay, transformations of graphs. Okay, so first of all, we talked about any graph in the world. Okay, to move it up or down, you should add the number to the end, right? So if you took that 7x, if you added 3, you move it 3 up. 2 down minus 2. 74 up, add 74. Works for every graph in the world because the y coordinate is becoming bigger. So here, in general, f of x, to move it p units vertically, the new function will be f of x plus p. And move things up and down, add number to the end. Okay, right, then, okay, sure, can I get this done in 5 minutes? Okay, horizontal shifts, so there's a different strategy. If you wanted to move it 5 to the left, what did you do? Every time you see an x, you change that x into x plus 5. It's the opposite. Okay, so change, when you're doing horizontal shifts, say change every x into 3 units to the right, change every x into x plus 3. So from this one over here, okay, y is equal to 5x cubed plus 7x minus 5. 4 to the left, change the x into x plus 4. Okay, 2 to the right, change it into, I've changed the x into x minus 2. Okay, if I had a sine graph, to move it 20 to the left, I change the x, if I keep it in bracket, into x plus 20. 3 to the x, 5 to the right, change the x to 3x minus 5. Remember this vaguely? Okay, 8 to the left, an absolute value graph. Change where the x was, replace the x with x plus 8. Fish? Okay. In general, if you've got a function f of x, to move it forward to the right, we rewrite it as f of x minus 4. That means turn every x into x minus 4. Okay. Then, reflections about the x-axis. If you fold something over the x-axis, think of a point. 3, 4 would become 3, negative 4. 5, negative 7 would become 5, 7, right? What's changing sign? Okay, the y coordinates. This, in algebra, negative y means what? It's the opposite. It doesn't mean it ends up being negative. It means it's the opposite of the original y. Okay. Then, 5x squared minus 3x plus 2. So whatever you do to a point, you do the same thing to an equation. So when I reflect a point about the x-axis, what change signs? The y coordinate, right? So you do the same thing in the equation. Okay. And this y over here, okay, becomes negative y, but then you get y on its own, and you divide everything by a negative. Okay. The effect is to reflect that whole graph about the x-axis. So if you had y is equal to negative 2 over x, it will become negative y is negative 2 over x. Divide by negative, you can skip our steps eventually, and you get y is 2 over x. If you had this, change the y into negative, y is equal to negative 2 over x. It will fold the whole graph over. Okay, so if you had the absolute value graph, okay, y is equal to absolute value of x, which looks like this, and you want to end up with a reflection like that, what do I do to the equation? That y becomes a negative y is equal to absolute value of x, divide by negative, you end up with that. Okay, okay. So in general, you end up with y is equal to negative that. Okay. Do you have a sister at school? I don't think you did. Somebody told me the sister in trick. I like you. I had them down and killed him. Okay. Well, maybe you just don't know. Right, okay. Life is full of surprises. Okay, if you fold about the y-axis, okay, what happens if you've got points and you fold it about the y-axis? What changes sign? X. Then 3 becomes negative 3, negative 5 becomes 5. In general, x changes signs. How do you say that mathematically? X becomes negative x, opposite sign, right? Okay, so if you had this function 5x squared minus 3x plus 2, and you wanted to fold it over the y-axis, wherever there's an x, you replace it with a negative, right? Okay, and we end up with that. Okay, here replace the x with a negative, change every x into negative x, change every x into negative x. Okay, with absolute values, okay, if I change every x into a negative x, I end up with y is equal to absolute value of negative x, which is just the same thing as y is equal to absolute value of x. Because think about it, it's symmetrical about the y-axis. So if I fold it over the y-axis, I end up with the same graph. Okay, right, then we go to you. Okay, if you do a double shift, okay, so you're going to go take that graph, move it 2 units up, I add 2 to the end, right? Okay, if I want to move it, okay, 3 to the right, change that x into x minus 3. So then we just combine the whole things, okay, and then we did the same thing over here. Did I make it under 5 minutes? How many times have I done this?
45 seconds.
Okay, so we'll show you just, so in general, if you had an absolute value graph, which is what we're going to get back to, if you've got y is equal to the absolute value of x, and you want to go 2 to the right, I change the x into absolute value of x minus 2. So I change this x, okay, into x minus 2, and to move it 3 up, I add 3 to the end. Okay, so what will the effect on that graph? Well, if you had the graph of absolute value of x, that new graph would have done what? This point, instead of being at 0, 0, would have gone 2 to the right and 3 up. And that'll be that graph over here. My salient point at 2, 3. Okay. So if you understand shifts, you can look at a function, okay, and figure out what's going on. Not too bad, Roger John. Okay, right. Yeah. Yeah. It's actually cold there with the water.
The breeze is chilly.
Yeah, it's my aliens are saying the same thing. Didn't believe it. Okay. Alright. How was your trip?
Very fun.
Fun.
Yeah, I just got a bit tired of the grades in life.
Okay. You the only guys in?
Yeah, and then there was Izzy, so we were the only students.
Oh yeah. It's a good match. Were you in the same place? No.
We were in split the whole time.
What's it like?
It's oh no.
Nice.
Yeah, but we didn't really explore much. Like
okay.
we're kind of just around the hospital and the beach.
Okay. Alright, how were the split-ins?
They were a bit odd. They were very odd.
Were they?
Yeah. I really like it.
Did you also like iced tea usually?
Yes, sure.
The
My
fused
street
one.
was 4. Okay, yes, the fused one. But the on the peach and
So why didn't you guys make some money? Import that iced tea to South Africa.
Sir, you know
and
my
sell it.
suitcase was 4 kgs every year because it was full of iced tea.
Really? You put iced tea back on the plane?
Yes.
Alright.
Of course.
Alrighty guys.
Don't my pantry now.
Right. Anyone feel like reading for me? I'm talking a lot. Okay, right, function notation. Right. Go for it, please, Sunny. Right, we're reading on page 25. I think it is 24. Function notation. Right, quiet, follow along. Right, and on your mark, get set, go.
Just like your parents gave you a name, functions can be given names for the sake of convenience. These names are not very exciting and are denoted by a single letter. For some reason, often F or Z or H.
I don't know why. Okay, so just like you were given a name, because it's a pain in the arse, you have to say every single time. Okay. That person over there who, I don't know, what do we say? Who gets the hell in sometimes, with good reason though, always with good reason. Okay, then you'll have to say, who's that? The person who's scared of moths, who is that? Were there moths? Who's this? No moths. Okay. Right, okay. So, functions are just given names, so we can refer to them. It's easier, right? So if we had f of x is equal to 2x squared minus 4x plus 1, this is another way we can write functions there, guys. Okay. It means the same thing. G plots x to 4x plus 3. It just means you change it to get a y. So G is like a machine, right? Okay. If you put things into G, if you put an x value in, what comes out is, what do you have to do to that x value? You have to times it by 4 and add 3 to get the output value, and that output value for us is normally just the y value. You with me? Okay, so that notation is the same thing as g of x is equal to 4x plus 3. It will result in the same graph as y is equal to 4x plus 3. But this notation is often more convenient. Okay. So, we can talk about the graph f and the graph g without having to write it down every single time. So instead of saying the time every time the graph y is equal to 2x squared minus 4x plus 1, I can just say graph f, graph g. Okay? Just makes life easier. Okay. So if you're given f of x is 2x squared minus 4x plus 1 and g of x is equal to 4x plus 3, okay. If you've done this notation, you should have done it. Okay, try to answer those questions.
So is this for order, do you do the brackets x, comma, whatever it is?
Sorry?
Brackets x, comma.
Could you remind me to
Or doing,
Yes.
so do you?
You've got x pulled down and y pulled to this level goes.
Does Esme have a pocket? Does she still? I don't know. No, it is.
Our recording lessons you guys missed on Friday. I don't know if you have it. Where's your camp? Where are you going to? Where, which, you know what the ring is?
Apparently the one that's the same that you went to grade 8 is on
Okay, it's very nice. What time do you guys eat?
We did not go to
What?
camp discovery.
Whoa. No, but what time? No?
Oh, so it's
Grade 11, we leave at 6. Grade 11.
So S is 2 and.
Alright.
Oh, they want us to draw the coordinates that we just need.
Oh.
Six to one.
I think so. I don't know if that's correct though.
Right, so guys, what does f of 2 mean? F of 2 just means go and replace every x with it. 2, right? So you get 8 minus 8 plus 1, am I right? Which is 1. So guys, you need to understand this. We worked out that f of 2 is equal to 1. If I tell you that, what does it tell you about a graph? What's the point on that graph? Terminator? Yes. 2 and 1 is the point in that graph, right? On graph, what this is saying to you, on graph f, whatever that happens to be, when the x coordinate is 2, the y coordinate goes with it is 1. Okay, that's what I mean, guys, by the associated coordinates. Rich?
Yes.
Okay, so try the next one. You haven't got a jail someday, no? Savannah? No. You go away. Keep double running, eh?
Yeah.
Thanks, man.
You're working on our campaign.
No, I couldn't wait on that.
No?
Because what's his name? Country left the EFF guys and then messed up our campaign. One of like his prime.
Oh, yes,
time.
that guy. Floyd Shabambu.
Our EFF youth league. You don't know about our EFF youth. We've been campaigning for it since January. You haven't seen our dance even.
Our rap.
Oh,
Right, g of negative 1, right, so what? How do I work out g of negative 1?
G of negative 1 equals to 4 open brackets minus 1 plus 3,
Which gives you?
which gives me negative 1.
Good. So Gabby, what's the point on this graph?
Negative 1, negative 1.
Good. When x is negative 1, y is negative 1. Okay. Are we good, guys? And you just, yeah, you guys have to train hard this one.
Yeah.
Hard as the polygon.
It's around like 6 days a day.
Yeah.
Did you?
Yeah.
I just like
Crap, that's
It's
a
like the
lot.
butterfly.
You got 6. Okay, is made a proper.
I have 2 days, only 6 straight. I've only had like one evening, one night time. I was one day.
Is your cough gone now? I think it would have been for words to have a
We
cough.
always have concerts.
Yeah.
Okay.
I always have a
Are we
ready.
happy with that, Nina? Okay. Right. Okay. Right, next one says determine f of naught. Tell me what f of x was again? F of x was? What's that equation?
2x squared minus 4x
Plus?
the equation at the top. Plus 1.
Plus 1. And g of x was?
4x plus 3.
Okay, so try the next two questions. Why is it not a bad start to the season, eh? Well, you might start crap. So I don't know what it means yet.
So it's such an importance of F, but we have G. So it's only.
Okay, so the previous one, did I ask the question incorrectly? Okay, on G. Okay,
This one here says on F.
let's see. On F, this one should be, yeah guys, this should be on G. For D, sorry, thank you, Nina. That should be G.
Oh, for D, it should never let itself get clear.
It should be epsilon.
Yeah.
No.
That's not bad you're looking at it, I think.
It was just so shocked by the and the magnitude of
If you quickly
E
change
equals
the
MC.
screen.
It's gone, because you know E equals MC is suspicious. And you know, you can just.
You actually really want to you speak shit well.
Thank you.
Yeah. Right, F of 0. Okay, and A?
Yes, sir.
I'm making you swear in monitor, but stop swearing. Okay, I swear I have to do 20 push-ups. No.
From now on,
Now.
like right now.
But instantly, I have to do it there and then, not like in the brain when it's there.
Okay, so.
Right. Also, I've got to get fixed. Okay, determine F of 0 and state the equation. Okay, so F of 0. F of 0 is going to be 2 times 0 squared minus 4 times 0 plus 1, which is 1, right? So what's the associated point? 0, 1, right? Okay. Just out of interest, that point's got a special name on that graph. What is that? What's the point? Yes, you see it? Well done. Okay, this is your y-intercept, right? Because when x is equal to 0, the y-coordinate is 1. So 0, 1 is your y-intercept. So in general, f of 0, when you're working on f of 0, you're finding the y-intercept on whatever f happens to be. Okay?
No, actually, I'm not that sure, so don't copy now.
Alright. Okay, and to work out, if solve g of x is equal to 0, does that mean I have to replace every x with 0, Masana?
Yes.
For d?
No, it's just 4x plus 3.
Thank you, Masana's rescuer. Right. Okay, I'm solving g of x is equal to 0. That does not mean I go replace x with 0. It's saying, what is g of x? It's saying go solve this. So that's why it says, given g of x is equal to 0, go solve for x, and hence state a coordinates on g. So go figure out x, and write down the associated coordinates. You know what I'm saying?
Oh, but then I have to. That's a very kind of. Why is it like?
So what are you getting there for x?
-3.
Good. So what's the point on the graph that you just worked out? So what's the coordinate going to be?
-3 over 4.
Yeah.
And 0.
Okay, so if they say to you g of x is equal to 0, guys, what they're really saying is when the y coordinate is 0, okay, what is the x coordinate go with it? So this thing over here, and it was called the what?
X-intercept.
That's your x-intercept. Okay. So in general, guys, we'll have a break just now. Okay, if you've got h of 2 is equal to 0, okay, so try complete that, then what's the point on h? 2 and?
0.
Right, try finish that. Okay. If it makes sense. One hour ago. Yeah. Neat. Running the he lives about an hour.
How do you keep the visit?
Okay, it's a surprise visit. Okay. And you see those guys who have to sit on the front of the vehicle? You know when they crack on game drives? And you've got the vehicle in on the very front, above the number plate, there's a little seat there. The program had to do the other day, and then they came across 12 lines on the road. You need to sit there. So I'll look good. Right, okay. But you'll be proud of him now, eh? Hey, so that's the word. Short pants. Short khaki pants.
Hi.
Because he loves it, man. Right, okay. So, given h of 2 is equal to 0. So what's a point then, Sarah, on h? Okay, good. So what this is saying is that 2, 0 is a point on h. Sunny, you with us? Okay. Right, so h is equal to, h of 0 is equal to 1. What have you done there? You've let x be equal to 0. When x is 0, what are you finding? A y-intercept, right. So if h is equal to 0 is equal to 1, then 1 is the x-intercept of h. Am I right? No, wrong way around. Okay, so y-intercept. h of 0 is 1 is over there. My bad. So 0, 1 is a point on the graph. That's what we've worked out. So 0, 1 then is that. So 1 is the y-intercept. And Masana, if h of negative a third is equal to 0, well, where is negative a third 0? It's over there. So what would I know?
The x-intercept.
Then negative a third is the x-intercept of h. Hey, you have maths is a language, you have to understand the language, guys. Okay. Alright. Okay. Right. Let's have a look here. We will look at other techniques of sketching graphs which will save us time as well as give us a grounding and transformation techniques of graph. Back to absolute value graph. Now we did some absolute value graphs earlier. Go back? Or didn't we?
Yes.
Okay, if you go back, okay, we're going to have a break now. Okay, if we go back to these things. Okay, go back, let's have a little look at these and then we'll, before we start the next up, okay, we'll go on. Now remember, okay, let's just do 2 of them. I'll go to the previous. Okay. We had this definition. Just go back to page 18 of your notes. 18. You put you guys in 5 minutes to go break. Okay. On page 18. Okay. So remember we had this definition. I don't know if you guys remember this. Okay. The definition of the absolute value of x was what? The absolute value of something, what happens to it? If what's inside is bigger than or equal to 0, then it stays the same. But if what's inside is less than 0, then it changes sign, right? Remember that definition. It was going to be given to you. Okay. So if we had this graph over here, so the first way we sketched these, which was a pain in the ass, okay, we said if y is equal to negative 2 absolute value of x. Okay. If I use my definition, and I say if what's inside the absolute value is bigger than or equal to 0, then that stays the same. So what is that? And if what's inside is less than 0, then that changes sign. So in other words, an absolute value graph is made up of 2 straight line components, right? Okay, we drew the graph y is equal to negative 2x. When did I draw that? When x was, sorry, this is y, I drew y is equal to 2x when x was less than 0. So when x was less than 0, I went and drew the graph y is equal to 2x. But when x was bigger than 0, okay, I went and drew the graph y is equal to negative 2x. So this is how we've been drawing them up to now. If there were any intercepts, we went to find the intercepts. 2 minutes, guys, 2 minutes. Then, okay, so if I had this graph, and we did it using the definition, y is equal to x plus 3, what do I say? If what's inside, okay, is bigger than or equal to 0, then it stays the same. But if what's inside is less than 0, then it changes sign. So we ended up with an instruction, go draw the graph y is equal to x plus 3 when x was bigger than negative 3, right? And I drew in the split. Okay, that's not an asymptote, that's where the split happens, right? So when x coordinates were bigger than minus 3, which is this area over here, I drew the graph y is equal to x plus 3. But when the x coordinates were less than negative 3, because I've made x a subject of the formula there, you with me? When the x coordinates were to the left of negative 3, I drew the straight line graph with a negative gradient. Y is equal to negative x minus 3. Okay, and we did one more, I'll show you one more like that, then we'll have a break. Okay, and then we did on page 19, if we had this one over here, okay, y is equal to negative x plus 2 plus 1. Where did I do the definitions? I wrote it out. Okay, how would I, let's just practice one quickly. Okay, how would I draw this graph? Okay, using the definition. What would I say? But if I use the absolute value definition, what did I write? I'd get one situation if what? I always write the if bit first. If x minus 2 is bigger than or equal to 0, you can skip our steps, but I'll get another situation if
X minus 2.
right, terminator. If what's inside is bigger than or equal to 0, what happens?
It stays the same.
So it stays the same without the absolute value, right? So you get negative x plus 2 plus 1. Okay? But I know if what's inside is less than 0, what happens?
It changes to.
So it'll become y is equal to, I'm not going to write the y, sorry, it'll become y is equal to negative x plus 2, right? Just what's inside the absolute value changes. So in other words, I end up drawing, so stay with me for 1 minute. I get negative x, okay, minus 2 plus 1 is negative 1, if what?
Is greater than or equal to.
And I get x minus 2 if x is less than 2. So I have, am I right?
It's x minus 1 because.
It's negative x minus 2 plus 1 is minus 1.
No, the second one.
Second one, x minus 2 plus 1 is minus 1, eh? Minus 2 plus 1, am I right?
Yeah, minus 1.
Okay. So
The first one's plus 3.
negative x,
Is minus.
this should have been minus 2 here. I'm being a knob, sorry. Okay, that should have been x minus 2, right? So I get negative x plus 2 plus 1.
So that's minus 2.
Something's wrong.
Yeah.
Oh, wait. I need a break, right? If x minus 2 is bigger than 0, then it's going to be negative, that stays the same, x minus 2 plus 1, which becomes negative x plus 2 plus 1, which is plus 3, isn't it?
Yes.
Okay, right. And if x minus 2 is less than 0, it becomes x, that's right, minus 2 plus 1, which is minus 1. Am I right? Okay,
Yes.
right. So I get one situation when x is bigger than or equal to 2, okay, and another one when x is less than or equal to 2. Okay, what did I always say? You can find the salient points how? Okay, by subbing in what happens when x is 2, right? When x is 2, you get negative 2 plus 3, which is 1. That's why you hit the point 2, 1. You get 2, 1 on that one as well, right? Here, I draw the graph negative x plus 3, which is that branch over there. I do that for x is bigger than or equal to 2. Here, I draw that branch over there, x minus 1. Okay, it's pain in the arse drawing these things like that, but it is important to understand that ultimately, okay, absolute value graphs can be expressed of this form, can be written as two straight line graphs. I want everyone to get up, go for a walk to the end of the corridor, no options. Okay, when we come back, I'll show you a much easier way of drawing these things. Okay, go, go, go. Okay.
Gabby, have you ever heard of option check?
You enslaving me.
2 more minutes. When are you going to go to Poland or something, Nina?
Huh?
When are you going overseas?
Oh, next this year.
Sorry?
Next this year. I went on a road trip this one.
Okay. Right, let's go, guys. Alright, let's go.
It's too bright. The eyes are sensitive, okay? No, not really. So you shot. 我看到人家那时候一直会打那个 anti-testing minus correction. 我打算下午。I'm just telling you, sorry, can't be talking in assembly, can't be talking.
I was actually confusing more when they have any cheese.
You know about
No, actually, go fight.
We are actually feedback.
Maya, what did you watch?
But then all the time.
Sorry.
Yes, it was. It was fun. It was so much fun. And then it was warm.
Say not Arsenal, but Arsenal will come second. It'll be United, Arsenal.
No, don't jinx it, sir. It's a new season.
I hope so. Alright. Okay, yes.
I have a question. Why at the top where it says that negative x plus 2 in the brackets? Why is it like that?
I don't know what you mean by that. It's not a choice pen, it's just what was written there.
But then that's
Where? Here, there.
yeah.
Because if what's inside is less than 0, then what's inside the absolute value changes to sign. So the x changes to negative x, minus 2 changes to 2.
Because if you
If what's
just
inside the absolute value
yes.
is less than 0, I haven't distributed yet, then that x changes to negative x, minus 2 changes to 2.
Because in the question it was negative x plus 2. Yes.
Yes.
So then you change the sign for the second one.
You change the sign for the second one.
I'm leaving it up to you guys to sort that out. Okay, right.
This one, right? Write it as negative x minus 2.
Okay, so now I want to go
No, this also means the same thing. Yeah, I negative error.
to,
Instead of the negative outside. It's one way. You understand? Yes.
guys, I've been teaching quite a few varsity students this holiday. AP comes up a lot. Okay,
Yeah, we saw your message.
it really, that's why I want something I teach this and other people. And it really can help you a lot. I don't care about the mark, but if you might do something with maths in, it will help you a lot. Okay, and these are commerce students. Commerce, the UCT commerce students, and a lot of AP. Okay. Alright, so now we're going to use a much, this is a technique you're going to use always. Okay, just get absolute value graph. So anytime you have to know about that split, they say to you, what is the equation of each branch? Okay, so the way we're going to sketch these graphs is really understanding transformations. Okay, so it says, back to absolute value graphs. Okay, so it says we'll look at other techniques of sketching which will save us time as well as give us grounding in transformation technique of absolute value graphs, right? So back to just absolute value graphs. Okay. So we've got, if you had the graph y is equal to a absolute value of x, and A is some number bigger than 0, what's the shape of that graph going to be? Happy or sad? Happy, right? So your shape of that graph would be like this. So that's the first thing you've got to recognize. Okay? The gradient of each branch is determined by A. What I mean by that is if say I had y is equal to 2 absolute value of x, okay, the graph, this gradient over here, M is a symbol for gradient, right, would be equal to 2, and this gradient here would be negative 2. The one's positive, the one's opposite that, right? Basically, your two branches is that's 2x, that's negative 2x. Guys, stay with me. Okay. The salient points, okay, our graph, okay. So, what am I doing again? Okay, so the graph of the form y is equal to ax. So the salient points, okay, will be equal to, for these graphs, will be 0, 0. So we draw a graph of the form y is equal to a absolute value of x. Okay. So those ones, there's no numbers at the end. The salient point will be 0, 0. Okay? Then you're going to just simply choose one other point. Okay? That goes with it. Okay? And then you're going to use symmetry. It's basically like drawing a parabola. There's a lot of similarities with parabola. If I gave you this, you should have done these. You've done parabolas before, eh? And I said you sketch that. What will the turning point be? 0, 0, right? Okay, it hasn't shifted, right? Your turning point will be 0, 0. Happy or sad parabola? Happy, because that number is positive, right? Then all you have to do is do what? Find one other point. Okay, because there are millions of graphs that go, parameters which go through the origin. So if you stop there, you'll lose a couple of marks. Pick a random number. So if you pick x is 1, what does the y coordinate be? 1 squared, which is 1, times by 3, which is 3, right? So you'd have 1, 3. And using symmetry, if 1, 3 is a point in the graph, what's the coordinate of this point over here? Negative 1 and 3, eh? Okay. Finish. We're going to do absolute values of this form in exact. So these are absolute values of the form ax squared. Now we're going to do absolute, that's the parabola. We're going to draw now very similar ones, but a absolute value of x. Okay, so what I'm talking about is if we go to the next page, and right, so first of all, y is equal to absolute value of x. Go draw that. All I do is what? Okay. Right, all of these, by the way, have positive numbers in front. Okay? So, if I'm drawing y is equal to the absolute value of x. Okay? It's going to go through 0, 0. It's going to turn at 0, 0, right? Okay. If x was equal to, pick a number, 1 or 2. If x is, okay, sorry, 2. If x is 2, what's y going to be? You put 2 into this equation, what you going to get? You're going to get 2, right? So it's going to go through 2, 2. It's going to go through 3, 3, by the way, and all of those things over there. So it's going to go, that's going to be your graph. But if x is negative 1, what would y be? What's the absolute value of negative 1? That's the value of negative 1, guys? 1, right? So it goes through negative 1, 1, negative 2, 2, negative 3, 3, etc. Right, so you end up with these. That thing together makes up the graph of y is equal to the absolute value of x. Okay. Right, now if I said to you, go draw y is equal to 3 times the absolute value of x. Is it going to go through 0, 0 once again? Yes, if x is 0, y is 0, right? Okay. But now, if x, let's pick a number, pick 1 or 2 again. Okay. If x was 1, what would y be? It would be 3 times the absolute value of 1, right? And what's the absolute value of 1? Okay, so this graph's going to go through 1, 3. If x was 2, what would y be? 2, 6, right? You don't have to label all of these points. Okay, so the graph is going to do that. Okay. Just label one point on each branch, that's enough. So On the original one I had 2, 2, and I had negative 2, 2. On this one, what I meant by use symmetry, if you want to, if 1, 3 is a point on that graph, what's going to be another point on that graph?
Negative 1, 3.
Negative 1, 3, right? Or you can just use the equation. So this, guys, okay, and it's going to go through that point as well. So when we mark it, these are done with rulers, they're not parabolas. It's a sharp point. Okay, so you draw it with a ruler. Okay. That is, in red is the graph absolute value of x. What have I just drawn here? B is the graph y is equal to 3 times the absolute value of x. Okay. Now, just one thing which is important, guys, which is worth remembering. If I have this, okay, just remember, if you've got absolute value of AX, it means the same thing as the absolute value of A times the absolute value of X. Okay, that's an important idea. It'll make your life a lot easier. In other words, if I said to you, go draw the graph, y is equal to this, negative 3, absolute value of negative 3x, I would immediately rewrite that. Okay? How could you rewrite it using this logic? The logic I've used from there to there. What would that become?
Absolute value of negative 3 times absolute value.
Good. So that's the same thing as the absolute value of negative 3 times the absolute value of x. And what's the absolute value of negative 3?
3.
So that is the same graph as y is equal to 3 times the absolute value of x, which kind of makes more sense to draw. Okay. So with this one over here, how could I rewrite C?
Y equals half.
Okay, it becomes y is equal to a half, you don't have to write this step, times the absolute value of x. In other words, we've got to draw the graph, y is equal to
Half absolute.
half absolute value of x.
So what? Negative half. Absolute value.
No, because the absolute value of a half is just a half. Absolute value of negative 7, remember, is 7. Absolute value of negative 50 is 50. Absolute value of 50 is 50.
Oh, half is more than 0.
Okay. So if I drew this graph, y equals to half times absolute value of x, would it go through the origin? Yes, the salient point would be at the origin. But now, if x was 2, let's say, it's a nicer number to work with, what would y be if x is 2?
1.
Half times 2 is 1, right? So it goes through 2, 1, which is over here. And if it goes through 2, 1, what's another point it must go through?
Negative 2.
Good, negative 2, 1. And if I draw it, that should be a straight line, sorry. So this is a graph y is equal to a half. Sorry, same thing, absolute value of x. So this, guys, they'll ask any questions afterwards. What did I just say in this question? Sketch. Okay. So guys, if you look at a pattern, you've got a half x, you've got 1x, 1 absolute value of x, you've got 3 absolute value of x. If I had 6 absolute value of x, where would it be? 6 absolute value of x would go through 1, 6. That would be y is equal to 6, you don't have to draw it. But that would be y is equal to 6 absolute value of x. So what happens as this number gets bigger? Okay, this over here was, the coefficient of absolute value was a half. There it was 1, there it was 3, there it's 6. As the number gets steeper, the gradient gets bigger and the gradient gets steeper, you with me?
Yes.
And so similar with the parabola. Get x squared, 3x squared would be steeper, 6x squared would be steeper, 10x squared would be steeper still, you with me? Okay, if I said to you this, Nina, what's the gradient of this branch over here? If this is y is equal to half absolute value of x, what's the gradient of this branch? It's a half. And the gradient of this branch is?
Also half.
No,
Or negative half.
negative a half, right? 1 absolute value of x, what's this gradient going to be, Toto?
It's going to be 1.
Good. And this gradient would be?
Negative 1.
Negative 1, right? If I gave you this, Bianca, 3 absolute value of x, what's this gradient going to be? It's just going to be, this one would be negative 3. You with me? So this was 6 absolute value of x. What was that going to be? And that one will be negative 6. Yes. Okay. So I said to you, what's the equation of each branch, just by the way? What will be the equation of this branch? But y is equal to half x. And that one? Negative half x. Okay. So as that number changes, that's how it affects that graph. Okay. Right. If I go to the next page. Hang on, did I finish this page? Yeah. Okay. If you've got y, go answer those 2 questions. Right, try and read through those notes and fill in the 3 spaces.
So it says, and this is value of x.
Yeah, sorry. In the previous page, guys, thank you. The more positive value of a, the steeper. You should have filled in the word steep on the previous page, thank you, know? Okay, the steeper the gradient of each branch.
Look at it.
Yeah, this one. No, the one.
Okay, try those ones, guys, just fill in those spaces.
You can't just take it
Yeah.
Page 27.
I want to go to
You follow over the x-axis.
Yeah.
Okay, you just skip out the step. You can go straight to there. Okay.
Suddenly, oh, yeah.
So,
Yeah.
in the previous examples, when we did, is we would make both of them change the sign. So why did we not do that then?
Yeah.
Because it wasn't inside an absolute value. What do you mean?
Oh yeah, that actually makes sense, sorry.
Okay. If I had this absolute value of negative 2x, you're given it. I don't know if I'm answering your question. You're given that, you'd rewrite it like that. But here, I don't have to worry because there's no negative inside. I want to end up with just absolute value of x in there. And I've got that. So here, I would want to end up with just absolute value of x. I could rewrite it like that. No, that makes sense. Okay. So here, if I reflect that about the x-axis, you can skip out this step. And if you think of the shape, okay, if you reflect it about the x-axis, what happens to the shape? It becomes sad, right? Okay. So here, if a is less than 0, the shape you're going to have to fill in is that over there. Okay. These ones, the salient point is still going to be 0, 0. And we're going to use the same technique that we did with positive. Just pick x is 1 or 2. Okay, right. So go try and draw those 3 graphs. Okay. To the end of the page, we're done with that. the first one? Negative absolute value of x.
So why is straight line exactly?
Why are they straight lines?
Yeah, like.
Because when you split it up, remember, it splits up into two straight lines. Two equations. This equation would be y is equal to negative x. This equation would be y is equal to x.
Yeah.
Okay, we use the definition. So it's plain to use the definition. So negative 2x, if x was 2, y would be negative 4, right?
Yes.
So 2, negative 4 is the point. What's another point? Negative 2, negative 4, right?
No. So, do you say negative 4 or negative aura?
What?
Did you say negative 4 or negative aura?
I said negative 4.
Oh.
I said negative 4, right? I'm thinking negative 4. Right, okay. And last one, so that'll be negative 2x and negative 5x. Well, if x is negative 1, y would be equal to negative 5, 1, negative 5. So once again, you can see the gradients, the bigger the number, the steeper they ask you about that. Right, no. Okay, but once again, you understand how if I had negative 10x, it would be more steep. If I had negative a half x, it would be flatter. Okay. Right, let's see this lesson. Right, thank you. Okay. We will continue some board work soon. Okay. Thanks, guys. Send me now, eh?
Yes.
In the gym.
I take you.
Do you know any exercise you want?
We're gonna do some, don't worry.
Sorry?
Saskia, not just